In this video, I'm going to show you how to set up your KNIME environment to directly get data from the structural kinase database KLIFS using the KLIFS nodes that we've developed as part of the 3DECAM project. If at the end of this video you have any questions about KLIFS or maybe about how to use KLIFS with KNIME, please feel free to contact me, Albert Kooistra, at info@klifs.net. After we've set up our KNIME environment, we're going to build a small KNIME workflow that allows us to draw a small molecule, a reference molecule, and then also collect all the ligands with a structure from the KLIFS database. In the next step, we're going to compare all the structures from the ligands of the KLIFS database against the molecule that we've drawn in order to find structures that have similar ligands to the molecule that we've drawn. In this example, I will use belumosudil, also known as Rezurock, a ROCK2 inhibitor that has recently been approved by the FDA. Belumosudil currently doesn't have any structures available, so finding a similar molecule might actually provide us with some insight in how belumosudil might bind, and also how, as a starting point for modeling, for example. If you haven't already done so, you can download KNIME at knime.com. KNIME is a data analytics platform and it's also free to use. So go to the download page, register for help and updates if you want, and then you can download for your specific platform. I've done just this. So I've downloaded KNIME, and that means that I have the standard nodes that are provided by the installation. So the next step is to actually also add the nodes that allow us to interface with KLIFS. So to do that, go to the Help button in the menu bar, then go to Install New Software. In this pop-up, click on the Manage button and select the KNIME Community Extensions Experimental. So make sure that the checkbox is selected, then hit Apply and Close. Then in the drop-down, select all available sites. And then under KNIME Community Extensions, Cheminformatics, you will find the 3DECAM KNIME nodes. So hit the checkbox in front of that one. And then as an extra, I'm also going to install the KNIME Chemistry Development Kit nodes, because this CDK package also contains the nodes that we're going to use to calculate the similarity and also to sketch the molecule. So hit next, it will collect the packages, and then it will allow us to install this. Accepting the license agreements. And because it's experimental, we always get a security warning, but I'm going to install it anyway. And when it's done installing, it will ask us to restart KNIME. So just do this. So now we're back. KNIME has restarted. And that also means that if we go to the node repository and to the KNIME community nodes, we will find a few extra entries. So here we have the 3DECAM nodes now. And as part of the 3DECAM nodes, we have KLIFS. And of course, we also install the CDK nodes. Let's start with our workflow. Go to File and a New. We're going to create a new KNIME workflow. I'm going to call it KLIFS test flow. So now we have an empty canvas. And the first thing that we want to start off with is to actually being able to draw a molecule. So I'm going to search here for Sketcher, and the node that I find is the CDK structure sketcher. I'm just popping it in here and adding a small node for clarity. So if we configure the structure sketcher, we can get a pop-up with a canvas where we can draw our molecule, or in this case, I'm just pasting in the smiles of belumosudil and then pressing OK and execute. Here in the node monitor, we can already see that we have one output, but I'm also going to show you here in the structure output that as a result, we got one row for one column with Bellomoso structure here. The next step was to collect all the ligands that have a structure from the KLIFS database. So if we search for KLIFS, we find also the ligands overview retrieve. So this collects an overview of all the ligands that we have in the KLIFS database with the structure available. So with this, we don't have to configure anything. If we don't configure anything, it will simply collect all the ligands that we have available. And if we execute it and look at the output, we have nearly 4,000 entries with the KLIFS ligands, the PDB or heteroatom IDs, the name, the smiles, and also the INCHI keys. So now we have the KLIFS ligands and we have a reference molecule which we've drawn. So then the next step is to actually calculate an abstract representation of each of the molecules called a fingerprint that allows us to calculate the similarity between these molecules. So from CDK, I'm going to use the fingerprints node and just putting it in here and connecting it to the structure sketcher. I'm going to call it ECFP4. And I'll show you why. We're setting the column with molecules to structure, and the fingerprint type for this one, we're selecting the circular fingerprint and then the extended connectivity fingerprint 4, hence the ECFP4. And the 4 indicates that the molecule is broken down into pieces of a maximum bond length of 4. I'm just going to copy it and also link it to the KLIFS ligands. And we see that we get an error, and that's because we have to change the column with the molecules to smiles. So if we just open it up and press OK, it will automatically configure itself correctly. So when executing this, we will have all the fingerprints for all the ligands in KLIFS and also all our molecule that we've drawn. So now we have the fingerprints, but we also want to compare the similarity. In order to do that, we add the fingerprint similarity node and then connect the KLIFS ligands to the first input. And I'm going to now move the molecule that we've drawn below and then connect it to the second input. This order is important because it actually indicates what our reference molecule is. And we want to use the molecule that we've drawn as a reference and compare our reference to all the molecule that are going into the first entry. So that means as an output, we will get all the ligands from KLIFS with a score as to how similar it is to the molecule that we've drawn. So let's take a look at the configuration. We're going to compare the circular fingerprints for smiles with the circular fingerprints for the structure column. There's no aggregation because we only have one entry, so we don't have to do anything here. Just hit execute. And then if we inspect the results, we get the same results as from the initial KLIFS node. So we have the KLIFS ligand IDs, PDBs, etc. But at the end, we have two new columns. So the first one is the circular fingerprint that we've just calculated. And the second one is the Tanimoto score. And this Tanimoto score indicates how similar this molecule from KLIFS is to the molecule that we've drawn. And this Tanimoto coefficient ranges from 0 to 1. With 0, the fingerprint is completely dissimilar. To 1, the fingerprint is identical. So the higher the score, the more similar the molecule. Press OK. And now we're going to sort the output just to only get the best results. We're going to sort it by motor. And we want the best at the top. So we're going to do a descending sort on the Tanimoto column and press OK. Execute this one. And then still we have all the results. So all nearly 4,000 entries from the KLIFS database. So we also might want to apply a row filter. And in this case, I only want to look at the top 3 molecules that are the most similar to belumosudil. So if we want the top 3, we use the include rows by number. And then the first row will be row 1, and the last row will be row 3. Executing this, we get this as a result. So we have 3 molecules that show similarity to belumosudil. The score ranges from 0.357 to 0.586. And this one that's quite a high similarity. So let's just take a quick peek already at the structure. And you might already recognize some similarity here to belumosudil, but we'll investigate that in a bit more detail. So now we only have the ligands, but we also want to collect all the PDB entries. So we're going to go back to the node repository, search for KLIFS, and use the structures overview retriever. The input for this node will be the ligand IDs, and the type of inputs are then, of course, also the ligand IDs, nothing else. So this is the column, and this is the type. So make sure it's set to both ligand IDs, otherwise we'll get very strange results. Hit OK. I'm going to just add a quick note here. Collect PDB entries. And executing this. So now we have 9 results. But if we look at the PDB column, we see that we have 4 with the same PDB code, but alternate chains. 4 with another set of PDB codes with alternate chains and alternate models. And we have 1 entry with just 1 chain and nothing else. And this last one is also the one with the QIG ligand. So that's the one with the most similar ligand. So let's take a peek at this structure in the KLIFS database. I'm going to go to KLIFS here, search for 3GXL, and we get this 1 entry. So we have the PDB, and looking at this, we already see the molecule again. Let's click on this, and we see that it's a TGFBR1 kinase in DFG in conformation and the alpha C helix in conformation, and a lot of other information, of course, that has been annotated by the KLIFS database. And here we see the structure. If we click through the 2D formats and just looking at the top, we might see some similarity again to belumosudil. Just going back to belumosudil. So this ligand is actually a part of belumosudil, so it has a high similarity to this structure, a substructure, and this tail is where it really starts to differ. So it's nearly identical in the main scaffold, and then we have this tail here. So that could indicate actually that this part would bind in a similar way, and then this tail would fit here into the back pocket. So that would mean that belumosudil most probably binds in the DFG out binding mode, and that the tail would then go into the back pocket, whereas we have this amide moiety that might then interact with the DFG motif. So this might provide a good starting point to start modeling the binding mode of belumosudil and also to get some insights just in to how belumosudil might bind. Just going back to the workflow. So now we have the PDB entries collected, but if you want to continue with analysis from within KNIME, that is possible. So you can, for example, add a structures retriever node from the KLIFS database. You can collect this to the structures overview retriever. And if we open this up and configure it, you see that the input will be the column with the structure IDs, so these have to match. And then the type of structure that will be retrieved has to be selected here. So you can make your choice from either, for example, the complex in Mod2 format or the complex in PDB format, all of course aligned and processed by the KLIFS database, or just the protein in Mod2 format, or only the pocket in Mod2 format, as well as the ligand. For now, I'm just going to select the ligand in Mod2 format. And this ligand in Mod2 format is the ligand in its binding mode, the way it binds into the protein, because it's just directly extracted in 3D from the structures. So for each of the entries that we had, so the 9 different entries, we now have the Mol2 structure of the molecule. So that's the end of this KLIFS workflow. And I'm just going to show you that also these steps are available in the KLIFS website. So if we go to the website and go to the drugs page, we're going to search for belumosudil. We see belumosudil, Resarock with the structure. It has been approved in 2021, and there are currently no structures available. But there is this button, Find Structures with Analogs. And if we click this, it will perform a similar analysis as to the workflow that we've just developed. And at the top, we also find the 3GXL. So that's indeed, again, with a high similarity score. But this is a slightly different fingerprint, and we're doing this in a slightly different way. And if we hover over the ligand, we can see that belumosudil and the ligand right next to each other, and we see how similar this core scaffold is of both ligands. If you have a structure of a molecule that is not already in the drugs page, for example, then you can repeat this by going to the search page. On the search page, go to similarity and substructure, and you can either draw your molecule here or paste in the smiles and then click draw, and then you see your molecule. The type of search will then be a Morgan fingerprint, so ECFP4-like, and I'm going to set the cutoff to 0.5 or higher. So that would mean that we will get only the highest hits. I'm going to search, and indeed, because of the very high cutoff, we only get the 3GXL as an output, and that is then also the similarity search, but performed in a slightly different way. So thank you for watching, and remember, if you have any questions, please don't hesitate to contact me at info@klifs.net.